So here I have a tank filled with gas, and these little dots represent some of the gas particles that would be in this tank. The arrows I put in here because all of these particles are in constant random motion. They're like a bunch of hyperactive little kids, running into each other all the time, banging into the sides of the container and so forth. So we've got this tank of gas. Let's think about the characteristics that we could use to describe it. All right? So one of the things that we could do is we could say what its temperature is. The higher the temperature, remember, the faster these gas particles are moving around. So temperature is very important when we talk about gas. Temperature for gases should always be reported in Kelvin. So we could say, for example, that the temperature of this guy here is 313 Kelvin. That's how hot these gas particles in the sample are. When you talk about gas, another important characteristic is pressure. All right? How hard are these gas particles bouncing against the side of the tank? How much pressure are they exerting on them? And we could measure these with, a pressure gauge or something like that on the top of this tank. We could say, I don't know, the pressure for this is 3.18 atm. All right, that might be a pressure. And another thing that we spend a lot of time talking about when it comes to gas is volume. And again, I have these letters here that are how each one of these things are abbreviated. Volume V, the volume of this tank might be something like 95.2 liters. And finally, look at these particles that I've drawn, right? There's a certain amount of gas that's in here. And the amount of gas, which is abbreviated by the little letter n, is usually reported in moles, which is a convenient measure of how much of something we have. So we could say that the amount of gas in this tank is, 7.5 moles. Now, whenever we have a sample of gas like this, if it's a tank or it's in a balloon or wherever it is, we can give it these various characteristics. And it turns out that also for any sample of gas, if we know 3 of these characteristics, we can figure out what the 4th is. All we need to do is know 3. And in order to do that, we use an equation that's a representation of the ideal gas law. And it's written as P times V, pressure times volume, equals N, the amount of gas, times R, times T, temperature. I'll get to R in a second. Don't worry about it for right now. It's going to be a number that we know. Okay, so let's say, for example, that we didn't know what pressure was, but we still knew the temperature, volume, and the amount of gas. No big deal. We could take the equation PV equals nRT and rearrange it, divide both sides by V, get rid of the V, and then we'd have P equals nRT divided by V. Plug these values in and we could figure out what the pressure was, okay? Or let's say that we knew what the pressure was of a particular gas sample, we knew what the temperature was and the volume, but we didn't know what the amount of gas was. We didn't know how much we had. We could figure out that 4th characteristic by rearranging the ideal gas law for N, canceling out R and T on one side, rearranging it to solve for N, and then we could plug in the pressure, the volume, and the temperature, and we could figure out the amount of gas. So in other words, if we know 3 of these characteristics, we can always figure out what the 4th is. So you may be asking yourself, okay, so R, what's R? R is what we call a constant. It's a number that we know ahead of time that doesn't depend on the variables in our problem. The R that I'm going to be using most of the time for the videos is 0.0821 liters times atm divided by Kelvin times mole. Now notice that this is a fraction. It has both a top and a bottom, and it also is not just a number, but it has units. And check this out. The units on R match the units in my problem. They match the characteristics that I'd be using, right? So I have liters here, liters there, atm, atm, Kelvin, Kelvin, and moles, moles. You always want the units on R to match the units of the characteristics in your ideal gas problem, okay? So because you always want the units to match, there are also different values of R, although I'm going to be using this mostly for the videos I'm doing. For example, Let's say that instead of ATM, I was using a pressure that was in millimeters of mercury. In this case, I wouldn't want to use this R here. I'd want to use this R here so that the units match. Millimeters of mercury here, millimeters of mercury here, and the number's different, 62.4. So again, that's what I'd use here. Let's say that instead of millimeters of mercury, my pressure was given to me in kPa. I would then use this value of R so that the units match. I've got kPa here, and all the others are the same. So 8.31 for that.